Hey guys, and welcome to Newton Part 4. This is where we're working with Newton's second law, and there'll be two variables that we need to calculate. This is Part 4 of the series that's on the Gumroad. This one I will also be putting on YouTube just because I think a lot of children struggle with this one. But if you need more help, you're welcome to go check out on Gumroad and see if you are interested in any of the other videos that I've made. But let's jump right in. Alright, so here we've got two blocks and they're connected by a string, and they ask us to determine the acceleration and the tension in the string. Alright, so that means this F tension is a variable that we don't have, and the acceleration of the system is unknown. So remember, Newton's second law says force is equal to mass times acceleration, and we have to go break down our F net. So let's make this block 1 and this block 2, just so that we can go write down all of the forces that are acting on them. So on the first block, what we have is the F tension pulling it that way, and we have the F friction pulling it in the opposite direction. My second block has got the F applied pulling it that way, the F tension pulling it that way, and the F friction pulling it back as well. So if we have a look nicely, we'll see that my second block has got 3 forces, but my first block only has 2 forces acting on it. For that reason, I'm going to start with the first block because it's got less variables. So we're going to start by saying my F net is equal to mass times acceleration. My F net being my F tension minus my F friction, which they gave to me as 7 newtons. My mass I have is 10, and my acceleration is also unknown. Now it's very important to note, because I made my F tension positive in this equation, my F tension has to be negative in that equation. Right, so just keep that in mind. So let's go work out the equation for the second block. So here we're going to say F applied minus my F tension minus my force of friction is equal to mass times acceleration. My applied force is 100 newtons. My tension force is unknown. My friction force they gave me is 10 newtons. My mass is 15, and my acceleration is unknown. What I'm going to do now is I'm going to use simultaneous equations. So I'm going to go back to the equation that has the least amount of variables. So the first block, and I'm going to bring that 7 across. Be very mindful of your signs here. Now I'm going to take this information, my ft, and I'm going to put it in over there. Here I have to be so careful of my negative sign. So I'm going to say 100 minus, in brackets, I have to go put everything that I got over here. I'm going to sub in there, but I have to put a bracket so that I can remember to multiply that negative in. Okay, and from there, I can just go ahead and solve it. And then, I'm supposed to be working out acceleration. So my acceleration, I can just go and solve with basic mathematics. And once I have this, I can go back to that step over there and just sub it in there. Right, let's go have a look at one that's on a table. Alright, we have two blocks that are connected by a string. The one is on top of a table and the other one is at the bottom of the table. we need to calculate the acceleration and the tension in the system. So once again, I'm going to break it down into two blocks. This block is the only one that's going to have friction. So let's call this my first one and that my second one. So if we have a look at all the forces that are happening on the first block, we have our Ft pulling it that way, and we have our F friction holding it that way. My second block has got my Fg pulling it down and the F tension pulling it up. Now remember, the two forces that the force that they share is my F tension. So if I make it positive in the one, it has to be negative in the other one. Alright, so let's start with this one because I think it's going to be the easiest one. So I'm going to say my F tension minus my Fg is equal to mass times acceleration. My F tension is an unknown. My Fg I can go and calculate. Oh my goodness, my signs are all over the place. And then let's go have a look at this one. So my Ft was in the front here. So here this one is going to, my Ft has to be second. So the sign has to be negative. So I'm going to say 7 minus Ft, because this was my F friction, is equal to 10A. So now I can go and get one of them alone. And then in Ft's place over there, I can sub that information in over there. And I'm going to be left with, once again, I'm very mindful of that negative. So I write it in a bracket so that I can go and multiply it in. Right, and once I have that, I can put my acceleration in there to get my Ft. Right, and that's the end of that one. Let's quickly go have a look at lift problems. So when dealing with elevator problems, we have to choose the direction of the acceleration as positive. It's just going to make your life a lot easier. So with my lift, I'm going to make my Fg positive. Right. If a lift accelerates upwards, the tension in the cable is going to be greater than the force of acceleration. So here we have a lift. So if it accelerates up, it means, and this is obviously my Ft and this is my Fg, it means that my Ft is going to be larger than my Fg. So if my lift is moving upwards, the tension is more than the gravity. If my lift is accelerating down, it means my Fg is larger than my F tension. And if it's moving at a constant velocity, or it is standing still, then you know that your Fg is equal to your F tension. Right, so if we think about a scale, when something is moving upwards, right, the normal force, so in this case, my normal force is going to be greater, so here my Fn would be greater than my Fg, right? So my Fn minus my Fg is going to be equal to mass times acceleration. Right, I need to remember that. For this one, where it's accelerating downwards, it means that my normal force is smaller than my gravitational force, which means that my gravitational force minus my normal force is equal to mass times acceleration. And in this case, my gravitational force is equal to my normal force. Okay. Which is also something else that's very important to remember, something we touched on today, is that for this one, where it's constant velocity or standing still, so if something moves at a constant speed or velocity, or it is standing still, it means that there's no force acting on it. So if they tell you a car is driving constantly at 20 meters per second, what you know is that your force is equal to 0, and this becomes a very important part of your syllabus and something we are going to be covering in a lot of detail. I hope that's helped. I'll see you guys in the next one.